Hi there guys, in this video we're going to have a look at how we can sketch quadratics. Now, you should know a quadratic is what we call a parabola and has this U shape or this N shape. Now if we think back to the general equation of a quadratic graph, we have this. Let's put it equals to 0 for now. Now the part, the A, B or the C that determines this shape, this U shape or N shape, is this first bit. It's the A, the coefficient of x squared. Now what we say is if A is more than 0, therefore positive, for example x squared, 2x squared, we're going to have this first U shape. If it was less than 0, for example minus x squared or minus 4x squared, we would have this reflected N shape. So that's the first thing you need to realize. So a graph, a parabola can go in both of these directions. Now, if I draw on here, I'm conscious that this is going to cut off here. So a parabola, what it can do is, whether it's the U shape or the reflected N shape, is it will come down and it will cross the x-axis at 2 points. So we say that this has two different solutions or roots. So where it crosses the x-axis, we say solutions and roots. Now this one's quite hard to show. I'll do my best. Okay, there we go. So you can see it just touches the x-axis. It doesn't actually go past. So we still say it has two roots, but we say it has two equal roots. Now, just so I don't confuse you at this point, if you imagine this quadratic, so let's think, if we have that, if we were to solve this, we could write this as x minus 3, oh, that's a 3, please take my word for it, and therefore when we to solve this, we would just get 3. So we do have two roots there, but they're both equal, and therefore it could be this one. Let me just get rid of that. Is that going to work? There we go, that's better. And the other example we're going to have is if it doesn't cross the x-axis, and then we say it has no roots. I should put this word in here, no real roots. And we came across this in my completing the square solving video because I ended up with a negative square root. Now, we can test for this much easier than actually going through it and solving it, called the discriminant. And it's all to do with the quadratic formula and this part, the b squared minus 4ac part. So what we say is if you take the coefficients of your the graph that you're given, or the equation that you're given, if we say that b squared is more than 4ac, so if you can imagine on the formula the first part is more than it, so you're going to end up with a positive number. You get this. If you put in the coefficients and the b squared is exactly the same as 4ac, what you're going to have here is this scenario. You're going to have it just touching the x-axis, and the roots will therefore be equal. And if your b squared is less than, when you do this part, you'll end up with a negative number under a square root sign on the formula, and therefore it cannot be square rooted, and therefore it does not cross the x-axis. So we use this discriminant and these three factors to test what the graphs are going to look like. So let's try one of these out. I've just got to create a new page. So let's take something quite easy. So y equals x squared minus 5x plus 4. So, and let's just draw a really bad axes. Here we go. So the things you need to know is about solving this. So when we're trying to solve, we're always going to try and factorize first for two brackets. So let's do that. So the factors of 4 that make 5, well, we can do that. We can have 4 and 1, of course. So they need to both be negative to make, both be negative to make the minus 5x and multiply together to make the 4. So when we solve this, we get x equals 1 and x equals 4, which tells me it's going to cross there and there roughly. So that being 1, that being 4. Now, what's the y-intercept of this? You should know this constant term is the y-intercept. So that is going to be, for argument's sake, there. So I've actually proved it there. Let's have a look at using the discriminant. So if we take b to be minus 5 and a is 1 and c is 4, you can see that b squared is 25 and 4ac is 4 times 1 times 4, which is 16. So we can see that this is more. And then when we go back to the last slide, I showed you that when it's more, you do get the two different roots. Just reinforcing that. So what you need to do now is try. It's really hard on this software that I'm using to do this, but that's shocking. But you get the picture. You're going to have to try and do that. Okay, so in the next video I'm going to describe discriminants a little bit more, and you can in fact find this vertex point, the lowest point, or the minimum or maximum point by completing the square, but they don't seem to want this level of detail at this stage. So that's all we're going to expect you to do.